Good afternoon and welcome to the Kentucky Center for Mathematics. Today we are talking about developing multiplicative thinking, and our presenter today is Bonny Davenport. Bonny, I look forward to learning from you.
Thank you, Kelly. I am Bonny Davenport, and I'm the regional consultant over here in Western Kentucky. Very happy to be with you on this last day of April. I cannot believe that. That's my little pumpkin, my little Asher, and I appreciate being on here every day at 1 o'clock, 2 o'clock Eastern time. But I really love the fact that my son goes, "Are we going to go see the people? Are our people going to be on?" And he's growing up in that culture where, you know, people talk about math, people do math. So I appreciate you guys so much every day. This is our website, as Kelly was saying before the session started. Any resources or trainings that you might have missed, you can go back and check out those resources. You can check out the trainings. You can see what's coming up and kind of plan how you're going to spend your days with us. Okay, so today's agenda, we're going to talk about the standards, then we're going to do some math and talk about the research and what derived facts from multiplication looks like. We're going to talk about doubling, break apart, adding a group, subtracting a group, near squares, and how those relate to the properties of multiplication, and then just some last points to consider. Okay, so starting right off with the standards. These are our Kentucky standards for our friends who are joining us from other states, but they are very similar all across the country, and our standards are actually really laid out well. They incorporate the standards for mathematical practice. There's clarifications and how the practices are infused into these standards. So our first standard is to fluently multiply and divide within 100 using strategies, big word, strategies, as the relationship, because we're looking at relationships between multiplication and division or properties of operations. And then over on our clarification side, it talks about students determine multiplication and division strategies efficiently, accurately, flexibly, and appropriately. Exactly what we define as fluency here in Kentucky. And being fluent means to choose among strategies. And so right there in your standards, it's just saying strategy, strategy, strategy. And I love the note, reaching fluency is an ongoing process. It's going to take the whole year. It's not going to take Unit 1 or Unit 2. It's going to take a long time. Okay, and then our next standard is applying those properties of operations, and over in the clarifications, it even gives you a diagram of what that might look like and the different properties. And so now we're coming to the part where we're going to do some math. Okay, so we have these 4 hats, and you might have this problem on the board for your kids. And how can we figure out the cost of buying 4 hats? So if you will please do me the favor of considering this for just a moment, and then either unmute yourself or in the chat, and if someone will tell me what's happening in the chat, let me know how a student might figure out the cost of buying 4 hats. Each hat is $16.
Bonny, I think that the student may start thinking about it $1 here, $1 there, and portion it out. Thinking about that.
If it were thinking about that, the entire cost for $16.
Yeah, the entire
I'm sorry,
cost.
I should clarify. Each hat costs $16.
I think that some of my students would, they would have that 10 or that 16, and 10, they would add up 10, 20, 30, 40, and then 6, 6, 6, 6.
Okay, so they would partition that, or they would decompose that number into 10 and 6. I had a little hard time hearing you there, so I'm going to rephrase and you tell me if I'm wrong. you said 10 and 6, and they would do 10 times 4 and 6 times 4 and combine those?
Yes.
Okay, great, thank you. Anyone else have a thought there? Thank you so much for sharing.
A couple of folks in the chat box said that they thought their kids might skip count or do some repeat addition.
Skip count or repeated addition.
I like that Jamie said 16 plus 16 is 32, and then I needed another 32.
So you use the doubling strategy there. Great. Okay. So that's kind of what we're going to talk about today, is looking at all those different strategies, way kids think about numbers, and developing those derived fact strategies to help them become more fluent. So in Jenny Bay's book, Math Fact Fluency, Jennifer Bay Williams, I'll call her by her whole name there. In her book, Math Fact Fluency, she has these 5 fundamentals that mastery must focus on fluency. Fluency develops in 3 phases. Knowing foundational facts must precede the derived facts, and time tests don't assess fluency, and students need substantial and enjoyable practice to be able to become fluent. And this is a graphic that she uses in her book, and it talks about how procedural fluency, when we think about procedural fluency, we think about kids being automatic and fast. But if we want them to become multiplicative thinkers and use those reasoning strategies, we have to think about not only being accurate, but being flexible within our thinking. So accuracy, efficiency, appropriate strategy selection, and flexibility all lead to a fluent student who has that multiplicative thinking. And the 3 phases that she's talking about in her book, phase 1, counting, where the student counts with objects or mentally, and I think that someone had mentioned that. So solving 6 by 4 by drawing 6 groups, 4 dots, and counting all the dots. And I know we have as teachers have seen that many, many, many times. And then we want to move those kids out of that counting and into phase 2, which is deriving. And that's using the reasoning strategies based on known facts, like solving 6 times 4 by thinking 5 times 4 is 20 and adding 1 more group of 4. And I think someone else used that strategy when they were figuring out the hats. And then phase 3, mastery, where they efficiently produce the answer. They just know that 6 times 4 is 24, or they are so efficient and fast at their strategy that they can do it within 3 seconds. And the fluency phases correlate so nicely with the Pamela Weber Harris diagram that Dee and Julie shared earlier in the week, where we start with the counting strategies. And thank you, K1 teachers, for setting that foundation for our kids. Counting, 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 counting. And then within that counting are our additive strategies. So the counting is still there, and we've built on that. We haven't skipped it. Now we're going to do some more sophisticated combinations of numbers and thinking about numbers. And then within all of that is the multiplicative reasoning. So this is where we want to try to get our kids to by 3rd grade, thinking of in bigger chunks and having that multiplicative thinking. They can pull out counting anytime they need to, or go back to, I think somebody said adding groups. So they can pull those out anytime they need to, but we want to get them to the multiplicative thinking. Okay, so we're thinking about derived facts today. The foundational fact sets are 2 10s and 5s, 1 zeros, and the squares, like 3 times 3. That makes learning derived fact strategies possible. So once students have a good grasp on their foundational facts, they have that to automaticity, then we can go down and we can start thinking about how to use those to efficiently do the rest of the facts. Because I think I read that once you have all those foundational facts, there's only like, what, 15 of the facts left to even learn because of the commutative property. So the very first fact we're going to talk about is doubling. And somebody used that when they did the hat problem. And thank you so much for sharing. And the doubling is good when you're doing your 4s, your 6s, and your 8s. And what you do is you look for an even factor, find the fact for half of that factor, and then double it. For example, a student might be thinking, I don't know 6 times 8, so I think 3 times 8 is 24, and I double that to get 48. So I want you to consider the one in the thought bubble for just a moment. Using the double strategy, how might a student or we solve 7 times 6?
You could do, oh, wait, do you want us to answer?
Yes, please, Jamie,
Okay,
thank you so much.
So you could say 3 times 7, which is 21, and then double that to get 42.
Great, thank you so much. Oh, sorry. We, Jamie, the doubling strategy, and that's fantastic. She took half of 3 and saw that that was 21 and then doubled it to get her answer. Another way, one of the ways in the book that she talks about, that Dr. Williams talks about getting to those strategies, is using multiplication stories. There are stories, quick looks, and games. So a carefully sequenced story can encourage the use of halving and doubling. The area model, and you can look over there in that diagram, the area model can help students visualize how doubling one of the factors leads to doubling the area or product. So it starts with a problem. So the class is building a sandbox. The sandbox is going to be 2 feet wide and 8 feet long. What's the area of the sandbox? And the student multiplies 8 by 2, gets 16. And then you sequence that problem by adding on to it a second part that says you decide to make the sandbox 4 feet wide and 8 feet long instead. How can you use what you already did to figure out the new area? So it is using the doubling strategy, and they might not use the doubling strategy, and you honor all of those things, but just presenting problems that lead to using some of those doubling strategies. And then quick looks are another great way to encourage the use of doubling strategies. So you would start with that first, or you could start with the second slide there, and then sequence left to right, showing those slides and asking students, what do you see? How do you see it? And quick looks are so fast that students are going to develop those strategies like doubling so that they are able to answer the question. And not all students would do doubling on this one, but it might come out. And if that strategy came out, then you could really highlight it and say, oh, let's look at that strategy. Do you think it'll work again tomorrow on the one we're doing? And just building on those visualizations, because having visualizations really cements that learning for students. And then, of course, the games. So we've had quick looks, we've had a sequence story, problem, and now we have games. If you were able to be on Dr. Jenny Bay Williams' session with NCTM on Monday, she shared some files and she is allowing me to share them here with you today. And the first one is called Switch, and we're going to play that together. So let me get our switchboard. Here's our switchboard. I'm going to kind of lay it down there so you can see it. Okay, so what we're going to do is I'm going to draw a card. I need to read the directions here for just a second. So you write the multiples of 4 on the piece of paper. Easy squeezy. People can do this at home. You can do this in your classroom just really quick. And then you're going to shuffle the cards and lay them face down in a pile. I just got a pile of cards here. And then players take turns drawing one card and multiplying the card by 4. And then you put your marker on here. Then the next person goes. It's a lot like bump, and if you get the number that's already been taken, you can bump your friend off of there. So we'll play one quick round of switch. Let's see. Okay, so I'll go first. And I have a queen. Whoops. And the queen is a 0. So I'm going to put a marker, and our friends at home probably don't have those nice 2-tile markers, so I'm going to use a quarter for me and a penny for you, so I have covered that one. And now I'm going to give you your card, and if somebody would be so great to unmute and tell me what it would be, just multiplied by 4. So I'm going to give you a card, and if somebody just tell me what it is by 4. Oops.
40.
40.
Great. So then you would get your penny on 40. And I may have lifted this too high. Probably easier to see now. Okay, and so then I would play again, and I have this card, so that's a 12. And I would put my marker on 12. And then the game would keep going on. So what is yours? Queens are 0, sorry.
0.
Yay, thank you so much. So you would get to bump me off and replace with your penny. And that game could go on as long as you want it to, or you can make it to where whoever has 5 pieces on the board first wins. So it's a really easy game to play, and kids can play it at home with their parents. The next game is very similar. It's called Fix Factor War, and this is in her book, and it's game 32. And you get a deck of cards with kings and jacks removed. You put a 4 in the middle, and as you are playing, you're going to flip 2 cards. You'll flip one, and your friend will flip one, and then you multiply by 4, and whoever has the highest product is the winner. So if you and I were playing, I would put the 4 in the middle so that we could be reminded of what we're playing. And let's say I am this one and you are this one. So I would go first, and I would say, okay, 4 times 4. 4 times 4, that's a square. I know that one, that's 16. So, but how might somebody unmute and figure out what 4 times 7 would be?
Four times 4 is 16. So I need 3 more groups of 4. So I would add that to my 16.
Great strategy, thank you. Would anybody else have a different strategy?
You could go 7 times 2 is 14 and double it.
And that would be leading up to our strategy of doubling. So sometimes the strategy comes out and sometimes it doesn't, but they were both great strategies, so we want to honor both of those. Absolutely, great, thank you. So those 2 games are in your packet, and it's in a nice letter that you can send home to parents. You can send it home digitally, or you can print it out. All right, our next strategy is called the break apart strategy, and it's good for 3s, 4s, 6s, 7s, 8s, and 9s, anything really, where you partition one of the factors into a convenient sum of known facts, and then find the 2 known facts and combine the products. For example, I don't know 7 times 6, and that seems to be kind of a hard one. 7s are kind of hard for kids. I break the 7 into 2 and 5 because those are foundational facts. They're easy, and I know 2 times 6 and 5 times 6. So I know 2 times 6 is 12, 5 times 6 is 30. I add them to get 42. And I think somebody used that on our last one, the break apart strategy. So look down there in the cloud, and if somebody wouldn't mind to unmute and think about 6 times 8, and how would you break that apart, or how might a student, and there's lots and lots of different ways to break that apart to solve 6 times 8.
So I can see a kid breaking that 6 into 5 and 1. So 8 times 5, and then add one more group of 8.
Absolutely, thank you. Anybody else have another strategy?
They may do 3 times 8 plus 3 times 8.
Yep, going back to that kind of doubling, isn't it? Okay, great. Thank you so much for sharing those strategies. When students begin to break apart those numbers, using a representation is key to keeping track of their progress. And up there in the corner, I have an article that I thought was fantastic. If you are part of NCTM, and you can go onto the NCTM site and download that article. It's really worth reading. It's got lots and lots of information about how to teach multiplication. And keeping that thought of equal groups in the foreground of when we're doing multiplication. And that's the first example there. It's kind of blurry, you might not be able to see it. So thinking of the groups of things, 7 times 8 is 7 groups of 8 things. I don't know what that is, but I know I have to have 7 groups in the end. So I can divide that into 5 groups and 2 groups, things that I know. The next part is using an array to decompose the fact 6 times 4 there. And they used, you can see at the top, they've used the 4 times 4. They've used that square fact that they know, and then 2 times 4. And then down at the bottom is an area model, which is very useful. And Belle did a wonderful job explaining the area model and showing all kinds of resources for how to use the area model effectively. So if you go back to developing number sense on our website and look at Belle's presentation, she did a great job of explaining all about the area model. It's really good to use when you are learning about multiplication and when you are able to start distancing that setting and coming off the little squares in the area model and going in the array and going into the area model. Okay, so this is a game I adapted for something that's on NCTM. It's called Modeling Multiplication with Streets and Avenues. And if you want the original game that they have made, you can just click on that link down there and it'll go to the original one. It's pretty much the same, it's just a little bit different. So what your students would do is they would roll the dice. And so our friend here has rolled a 3 and a 4. So the 3 is going to be the streets across, and the vertical 4 are going to be the avenues. So now we've made kind of like a grid or an array. And then the students are going to think about how many stoplights would we have to put on our map. And a stoplight has to go at every point of intersection. So how might a student figure out how many stoplights would go on that array? And if anybody wants to unmute and answer that, that'd be great.
They may add 4 3 different times, 4 plus 4 plus 4.
Absolutely.
Could they simply just count the intersections?
They could, absolutely, they could count. They could cut this in half and use the doubling strategy of saying 6 and 6, or they could just count, or they could see 4 times 2 is 8 and another group of 4 here. So there's all kinds of different ways that students can see these different areas of intersection to do their stoplights. Okay, you may be familiar with this game, How Close to 100. It's one of my favorites. And up in the corner is the link to Joe Bowler's website, U-Cubed. And her article, Fluency Without Fear, which is great, and I encourage everyone to read it, and it is in your handout, along with all the games that go with that. And here is a video of 2 students playing How Close to 100.
How close to 100 can you get? Hi guys, it's Preenal and Jonathan, and today we'll be showing you how to play How Close to 100. Demonstrating today will be Ronan and Addison. Here's how to play. This game is for grades 3 to 8. The materials you will need are 2 different colored pencils, 2 dice, and 1 game board. This game is played in partners. The 2 players share a blank 100 grid. The first partner then rolls 2 6-sided dice. The numbers that come up are the numbers the player uses to make an array on the 100 grid. They can put their array anywhere on the grid, but the goal is to fill up the grid to get as full as possible. Player draws the array on the grid, he or she writes in the number sentence that describes the grid.
So in the interest of time there, I'm going to go ahead and log off there, but you can go back and watch the whole video for more explanation there if you would like to. All right. And so that is just a picture of the 2 different ways that you can play. You can play by yourself or you can play with a partner. And adding a group with 3s and 6s. So this is our next strategy. And I'm going to have to go really, really fast to get through the rest of them. I apologize. If you start with a nearby 2 5s or 10 stacks, and then you add the group. I don't know 6 times 7, but I do know my 5s. So I can find 5 times 7. I know 5 groups of 7 is 35, and I have to add 1 more group of 7 to 35, and that equals 42. So I'm just going to move on from really quick. I'm so sorry. All right. So this is another sequence number story to help you make sense of add a group strategy. And the sequence number stories come in 2 parts. The first part with a known fact, and the second part providing a change in the story so that the other group is added. So basically in this one, 2 ladybugs on a leaf. Each ladybug has 6 legs. Then a 3rd ladybug lands on the leaf. How can I use what I just did to find out how many legs I have now? All right, and then here is a quick sketch. Just writing when you're doing 6 times 7. Having those 7 groups. 6 times 7 means 6 groups of 7 because we really want to keep that equal groups in the forefront of the strategy work. And because kids might get confused without that solid foundation in the foundational facts, where I know what the helper fact is, but what do I do now? Do I add a 7? Do I add a 6? Do I add a 5? What do I do now? Okay. And then this is a game that comes from Origo, and one of the great things I think that has evolved is that so many different websites and just our population in general is really trying to equip parents with good information and good games to help their students at home still be successful in math. And I won't go to the website just in the interest of time, but it's really good. So on Monday, you're going to watch a video that talks about the strategy. On Tuesday, there's a hands-on game, and this is a picture of the hands-on game that they have on that day. It's just the 6 facts, and you are using, and within that video, it talks about using 5 as an anchor. So for the 6 times 4, you're going to say, oh, I know 5 times 4 is 20, and 1 more set is going to be 24. So, and then you'll come over here and you'll put your marker on 24. And then there's a game day that's online, and the online games are really, really good, and you can play with a partner at home. Okay, so subtracting a group is the opposite of adding a group. You start with your nearby 2, 5s, or 10 facts, then subtract the group. I don't know 8 times 7, but I know my 10s, so I can find 10 times 7. 10 times 7 is 70. That's 2 groups too many, and I have to subtract 2 groups of 7 from 70. And that is 70 minus 14 is 56. So 8 times 7 equals 56. And that explanation really shows the importance of students understanding that multiplication is about those equal groups. And here's a sequence number story for subtracting a group. And so Amanda's stacking cans on the shelf at the grocery. She's room for 10 rows of cans. She can put 6 cans in each row. How many cans can Amanda stack on the shelf? And then somebody comes and buys a whole roll of cans. So how could she use what she already did to solve the new problem? And this is the subtract a group fact that is on the Origo website, and it's very similar to what we've played. You add those 2 cards, then multiply by 9. All right, near squares. Just like addition facts, where kids get those doubles really quick, they get their squares pretty quick. And so you look for a nearby square, and you find that fact and add on or subtract off the extra group. I don't know 7 times 6. I use 6 times 6 and add 1 more 6 to get to 42. I don't know 7 times 6. I use 7 times 7 and subtract 1 more 7 to get to 42. So that's how you use your near squares strategy. I couldn't really find a near squares strategy game that focused just on that strategy. So I made one and we were gonna play, but I'm already running over my time. So if you are familiar with Kaboom and how much kids love Kaboom. So what I would do is I would pick a stick and it says 4 times 3. So I'm gonna say, oh, I know 3 times 3 is 9, and 1 more group would be 12. And I get to keep my stick. And then you would get a stick and do the same thing until one of us got a Kaboom. And then that stick means that you have to put all your sticks back in the pot. And the person with all the sticks at the end is the winner. Kids love that game. They get so mad when they get the Kaboom. Okay, so, and there's also this great game on the KDE website where you are looking at different representations of the multiplication problems and matching those sets, and that's included in your handout. And then this great game from our Kentucky Numeracy project on the KCM website. These games scaffold and build. I picked this particular one because it's using tiles and area models to help students multiply. And on the website, it goes through step by step on a video how to play these games. You're gonna have all those cards and you lay them out and you draw a card and you try to find one that matches your card to make a bigger array. And then you record it down there on your recording sheet. Okay, so we've talked so far about the commutative property of multiplication and looking at the arrays, and changing the order of the factors doesn't change the product. That's come out naturally in our gameplay. And the associative property, how we're breaking those numbers apart. It doesn't matter the grouping during multiplication, you're still going to get the same product. And if you remember in the standards, it didn't say they had to know all the names of these properties and do a worksheet, you know, with 50 problems of associative property on it. These things are going to come out naturally to where they can apply them during the games. And then the distributive property of multiplication. You can decompose a factor into add-ins, and the add-ins can each be multiplied by the other factor to find partial products, and then those partial products can be added to find the total product. And so we've done a lot of distributive property. Really all of those different strategies and games were the distributive property. And you can see there just how to apply the properties of multiplication using all these different games. Okay, so action, call to action here. When you are planning your multiplication unit, or you're planning, not a unit because it's going to take all year to really master these different strategies. Some questions that might stay in your mind are, what is the fact that I want to focus on? What strategy did we talk about that aligns with that fact? When I'm doing fours, doubles really aligns with that. What game is going to encourage the use of that strategy and highlight that strategy? What quick look or number talk can I use to support learning that strategy? And then how can I incorporate sequence story problems into my gameplay to support student thinking? Okay, so that was a lot and really quick. All of those resources and games and letters are in your handout that I've given to you that are in your handouts, or you can go to our website and get. So, time to share. Anything, and you can just put in your chat box, or you can unmute and share with me. Anything square with your way of thinking? Anything still circling around in your mind? Still have a question about something? Or is there a point you'd like to make? Just a few seconds to put some things in the chat box or to unmute and let me know.
Bonnie, several folks are really talking about your word intentionality. So asking those questions at the end, very intentional about the games that you choose. It's like curating a good museum, always having the right activities for the students. You are given a shout out for all the beautiful resources that you've provided.
Okay.
Tanya says she likes how the games help with a big, strong conceptual understanding.
Fantastic. Thank you for sharing all that. In our upcoming sessions tomorrow, monitoring and assessing multiplication. And you can follow us, Twitter, Facebook, on our website. And then I'm here to support you. KCM is here to support you. Please don't ever hesitate to contact me if you need anything, or if you need some more explanation about the things I rushed through. It's so hard to get that timing down. I want to give you every bit of information.
Bonnie does a great job. She takes a topic and she goes and casts her net wide and far in order to bring you some of the best materials that are out there. But Bonnie, I thank you. I keep thinking and making sure that it's about strategy, strategy, strategy. And that fact fluency graphic that we've really been referencing almost every week here at KCM, talking about those fluencies, is really becoming part of my soul. So I thank you for bringing that back. One of the things I think people are mentioning is that they really appreciate the conceptual understanding. So this is the time in the session where we really would like for you to unmute your mic and give Bonnie a couple shout outs. We like to hear you with our ears.
Yes, for me, I was never taught anything other than rote memorization with bare numeral flashcards or worksheets with bare numerals. And I'm old, I'm 45. It's always sad to me still to see how many classrooms are still using the exact same methodology that was used for me back in, let's see, that would have been 1983 and 1984 when I was using multiplication in the classroom. And I really struggle when I see teachers continue to do that. And so I'm very hopeful that other teachers will see these resources and they will understand the importance of doing things differently than what was done with us. It did not work for all of us. It did not work for me.
I'm a special education teacher, co-teacher, and my co-teacher and myself are constantly trying to find different strategies. We don't teach concepts, we teach strategies, and we let the kids try to, figure out what works for them. And this year we did a lot of personalized learning, and I really felt going into the test this year that our class would really do good. Of course, we're not testing, but That's why I just love learning from other teachers too, and listening, sitting in on conversations like this.
Absolutely, Kathy. Thank you so much.
Hi, I teach in just out of Chicago, and I wish that Illinois had you guys have such a great program. So I just appreciate all the resources you have on your website and these webinars. And also I just love to listen to the way you talk, because it's so different from us. So thank you for everything.
Thank you, and thank you for joining us, and join us every day and spread that mathematical knowledge all over Chicago.
We are so lucky to have such passionate experts here in the state of Kentucky. We really do share, and we really do care about each other. And for you guys out there, we have what we consider a mini NCTM conference. Our conference in March is always very vibrant. And so we hope that those of you that are getting to be friends of ours from across the nation will be able to put that date on your calendar next year, and we can see you in person. But every afternoon at 2 o'clock, we share the best of mathematics here at the Kentucky Center for Mathematics. And we are so glad that you chose to spend your time with us this afternoon. Thank you.